Namaste friends, welcome to Rhchemistry. So in this particular video I am going to discuss about Neet-Booster 2020 Solutions chapter. So very important chapter for the NEET exam point of view and also JEE exam point of view. But very important point is that within the lesser time you have to do the calculation part. That is the challenging part for any students. Remember that. So understanding the problem and try to analyze that problem within the shorter time. Yes. First question you can see. The vapor pressure of pure CHCl3 and CS2Cl2 are 241.5 atmosphere respectively. The weight of CHCl3, CS2Cl2 are given. Weight is given in solution. The vapor pressure of the solution they are asking. So here when you see this, remember this is about Raoult's law. Right. So total pressure is equal to, formula is, remember, P0 A into XA plus P0 B into XB. P0 B into XB. In this particular case, here you can see vapor pressure of pure is given, which means I can write directly as 200 into, here XA I have to calculate, plus 41.5 into XB I have to calculate. See, to calculate XA and XB, we need mass is given, molecular mass you can calculate so that moles you will get. So number of moles of one component to the total number of moles you are going to get it as the XA and XB values, right? So now, in this particular case, very important point is that. So here, see, CHCl3, molecular mass if you calculate 119.5 molecular mass I am talking about, which means 3Cl 35.5 into 3, 1 hydrogen, 12 is the carbon, like that. CS2Cl2 we will get it as, remember, in this particular case 85, correct? CHCl3 109.5, CS2Cl2 is equal to 85. Now in this particular case, see here, number of moles of CHCl3 I want, correct? Mass by molecular mass is how much? 11.9 is mass, 11.9 divided by molecular mass is how much? 119.5. So by seeing this you can easily tell immediately the answer is 0.1. Then N of CH2Cl2 is equal to, so 85 is there and 17 is there. So 17 divided by 85 is equal to 17, 5 is 85. 1 by 5 is nothing but 0.2. So total number of moles is 0.3. Number of XA we want means number of moles of A is how much? 0.1 divided by 0.3 I will write. Right? 41.5 into 0.2 divided by 0.3 I will write, because number of moles of that component divided by total number of moles of that component. Right? 0.3 I have written. Now you have to simplify this particular problem. So now if you simplify this, see, answers are very near, not much difference. So you can do it very easily. 1 by 3 it is. 0.1, 0.3 is nothing but 1 by 3. So 3 ones are 200 is there, means remember it is 66. I will write 66 here, almost 66. Plus, here you can see 2 by 3 it is just like 2 by 3. 3 ones are 41.5 means remember around 3 ones are 3. So 41 means 42 if you take 13 point, right? So 13. So 13 threes are how much? So like that. 39. 13 threes are 39. So I will take this as 3. Right? So 13. Right? So 13 into 0.2 is how much? So it is around, so 13 into 0.2, sorry, 13 into 2 I have to take, 13 into 2, because 2 by 3 I have considered, right? 13 to the 26 around, so 26, right? So now you add 60 plus 26 plus 6, right? 32 plus 60, 92. So 92, nearest 92 is which one? So definitely 94.3 is the answer. So very easy. So like this you can calculate. C is the option. Now ethylene glycol is used as antifreeze to reduce freezing point of water by minus 2.4 degree. What was the mass of the antifreeze required for 2 liter of water. So once again, if you see basic, you have to calculate what's the formula we have? Molecular mass of the solute is equal to Kf into 1000 into W2 divided by delta TF into W1. Now what they are asking, that is very important. W2 they are asking, correct? W2 is equal to M2 into delta TF into W1 divided by Kf into 1000. One thing remember, here I am writing the formula because I have to make you understand this particular problem. In exam you can avoid this, you can save your time. Now the thing is, what is M2? See, molecular mass of the antifreeze, that is ethylene glycol. Ethylene glycol formula is CS2OH, CH2OH. So that if you calculate molecular mass is equal to, you will get 62. You can calculate. So 62 into delta TF is how much? 1.86 into, right? 62 into 1.86 delta TF. Then sorry, KF is 1.86. Delta TF is 2.4. Sorry, 2.4 into W1 is how much here? W1 is 2 liter they have given. I will take it as 2000 gram because for water, remember, density is equal to 1. Hence it is volume or mass, it remains same. 2000 divided by Kf is 1.86 into 1000. Right? 1000 ones, 1000 twos are here. Correct? So now you can see in this particular case, if you solve 2.4 into 2, how much you will get? Around 4.2, right? Sorry, 2.4 into 2 means 4.8. 4.8. So 18 threes are. So you can calculate that, right? 18 ones are, 18 threes are it is. Right? Very simple. 62 threes is how much? 180. Nearest to 180, what is the answer? So answer is B. See, in the shortcut you can do it like this, right? 160. So 180, 160. You can calculate. If you have any doubts, you can comment. So right. So answer is 160. Now depression in freezing point of 0.1 m aqueous solution of HCl, CuSO4, K2SO4 are in the order. Now we know that delta TF is equal to I into KF into M, molality. Here molality is the same, KF value is constant, hence it is depending on I value. I value for HCl is how much? 2, because H plus Cl minus is 2. CuSO4 is how much? 1 Cu, 1 SO4. So 2 is 2. K2SO4 is how much? 2 into 1. So that is K2 means 2K, SO4 is 1 unit. So 3. 2 is to 2 is to 3, or you can write as 1 is to 1 is to 1.5. So answer for this question is A. Then fourth question. Two elements A and B. Two elements A and B form a compounds AB2 and AB4 respectively. When dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 degrees Celsius. 1 gram of AB4 lowers the freezing point by 1.3 degrees Celsius. The Kf for benzene is given. Atomic mass of A and B they are asking. So it looks to be difficult question, but when you think the basics of this particular question, it is very simple. So here two different formulas, which means the same formula, two different way we are going to write. So Kf is given, delta TF is given. Then what is the formula? Yes, delta TF is equal to Kf into 1000 into W2 divided by M2 into W1. Now you have to use this formula. Before that I will tell you, here I will consider it as mass of A as a small a. So that mass of B as a small b. Right? So now you can see mass of AB2. How I can write? Molecular mass of AB2, how you can write? So A is nothing but A plus B 2 times I have to multiply, right? So 2B, A plus 2B. Then mass of AB4, how you can write? Very simple, A plus 4B. Correct? A plus 4B. This is the basic thing. So this molecular mass you apply in this particular formula. So two different formulas you are going to get. Because delta TF of AB2 is almost 2.3. Correct? So I'll write it as 2.3. A for AB2, remember 2.3 is equal to Kf is how much? So 5.1 into Kf is 5.1 1000 into W2 is how much? 1 gram divided by M2 is how much? Mass of AB2 A plus 2B into W1 is how much? So W1 they have given 20 gram of benzene, right? 20. Then for AB4 it is 1.3. It is 1.3. Correct? Is equal to 5.1. It constant, 1000 constant, 1 constant. See here. So A plus 4B this time it is. A plus 4B into 20 constant, because this is also 20 gram only. Same solvent they are telling. Now solve these two. Solve these two means what? This divided by this will do. When you do this divided by this, 5.1 get cancelled, 1000 get cancelled, 1 get cancelled, 20 get cancelled. So here I can write it as 2.3 divided by 1.3 is equal to, this can also be written as, remember, 23 divided by 13. Right? Both are same. Is equal to, denominator of the denominator comes to numerator. Hence I can write this as A plus 4B divided by A plus 2B. If you have any doubts, you can comment. Right? I think you have understood. This divided by this when I do, numerator, denominator. Denominator of the denominator goes to numerator. Hence I have written A plus 4B divided by A plus 2B. Now you simplify this value. So when I simplify, remember I will get 13A, right? So simplification I will do it in black ink, right? 13A plus 13 fours are how much? So 52. So 52B is equal to 23A plus 23 2s are 46B, right? A and B will take it one side. So 23A minus 13A, remaining is 10A is equal to 52B minus 46B, so that's 6B. So that A by B is equal to 6 by 10 is nothing but 0.6. A by B is equal to 0.6. Now you see the form, see this particular options. A by B 0.6, definitely A by B 0.6. A should be less, B should be more. It's a common sense, correct? A should be less, B should be more. Then only you are going to get 0. In this particular case 6. Hence this option and also remember this option you can easily remove. Then two options left. We know that 48 by 52 will never get 0.6. It is one value, 1. 52 by 52 iddange. So but 25 by 42 you can see 25 divided by 42, right? So now you can see in this particular case definitely you are going to get 0.6. Calculate 42 ones are 250. If you take 4 6 are 24, right? 0.6 is the answer. So the answer for this question is A. Like this you have to solve. So think from the basic level. This was the question which was asked in AIMS, remember, which was asked in AIMS exam. So remember that. Now 1 mole of each of following compound is dissolved in 1 liter of solution which will have largest delta TB value. See, delta TB value directly proportional to number of moles of ions, that is I value. Now you can see HF, HBr, HCl, HI. HF is having more stronger bond, hence HF will not dissociate into H plus F minus easily. HBr also, HCl also, but HI is weak bond and is a strong acid, immediately give rise to H plus plus I minus. Because of that reason, remember, number of moles of ions will be more in case of HI. Hence the answer for this question is D. So remember that. Now, if molality of dilute solution is doubled, then the value of Molal depression constant will be. So hard, triple, doubled, unchanged. We know that Molal depression is what? Constant only. See, very simple question, but you may make it wrong. So if it is constant, it is not depending on molality. Remember, it is constant, so it is not depending on molality. Hence the answer is unchanged is the answer in this case. 7th, Van't factor I for dilute aqueous solution, right, of strong electrolyte solution of barium hydroxide is. Barium hydroxide formula BaOH twice. So hence it will give rise to Ba2 plus 2OH minus 1 plus 2. So total 3 is the answer. So the answer for this question is D. Right? So this is the 7th question. Then 8th question you can see. 8th question is, in this particular case, at 100 degrees Celsius, the vapor pressure of a solution is 6.5 gram of solute in 100 gram of water is 732 millimeter. If Kb is 0.52, the boiling point of the solution will be. So here what they have given you have to see. They have given boiling point of this solution. Boiling point to calculate, remember we need a delta Tb, because what happens is delta Tb is equal to Tb minus T naught B. Right? So Tb you can calculate only when if you know this delta Tb. T naught B is 100. T naught B is 100 degrees Celsius. That is water boiling point. Right? So boiling point of the solution to calculate Tb, we want delta Tb. How you can calculate delta Tb? So the formula delta Tb is equal to Kb into 1000 divided by 1000 into W2 divided by M2 into W1. This formula you have to use. Now here very important thing is they have not given, in this particular case W2 is given, no doubt, but which solute it is not given. Then M2 will not get it. So M2 also unknown, delta Tb also unknown, you cannot solve this question. Hence what they have given, vapor pressure of the solution, pure vapor pressure of the solution, 6.5 of solute 100 gram is given 732 millimeter, and pure vapor pressure you can consider it as 760 mmHg is the pure one, right? So by using that, what you can calculate, see, we will continue this particular problem later. Before that, what I will do, so if you use this formula, P naught minus P divided by P naught is equal to N2 divided by N1. Here what you get? N2. What is this W2 by M2 here? W2 by M2 is what? Mass by molecular mass means it is number of mole, it is N2 only, no? So this formula can also be written as Kb into 1000 into N2 divided by W1. Correct? W2 by M2 I have considered it as N2 here. So N2 I have multiplied. Now calculate N2 by using this. See, P naught is 760 I told, because it is a standard pure pressure. 760 minus 732 divided by. So once again 760. If they are not given also you can consider. N2 divided by N1 is how much? To calculate N1, mass by molecular mass of the water. Mass is 100, molecular mass of water is 18. So 100 divided by 18 I will consider. Right? Now 100 by 18 is, remember, 5.5 like that. Correct? 5.5 you will get. Right? That 5.5 I will multiply here. So that I can write as N2 is equal to 760 minus 732 is 28. So 28 into 5.5 divided by what I will do? 760 I will take. This to substitute here. Fine. When I substitute at this particular formula, Kb is given 0.52, right? 1000 is as it is, into 28 into 5.5 divided by 760 divided by W1 is how much? W1 is 100 gram it is given. 100 gram it is given. Now substitute. Now calculation part is very, very important. Remember that. So here I can do it like this. 100 ones are 100 tens are. Right? So now you can see in this particular case, what I will do is, so 0.52 into 10 is how much? 5.2. 5.2. Correct? So now 28 into 5.5, I will take it as 30 into 5. Both are same. 28 into 5.5, 30 into 5. 30 into 5 is 150. So 150 divided by 760. This I can write it as 1. Hey sir, how you can take 1? See here, I will tell you. 150 into 5. 15 into 5 is how much? 75. Correct? 15 5 is 75. I will take it as 150 is there, so 750. 750 divided by 760, 0.2 is there. 760 by 760 get cancelled is equal to 1. Hence, you use this formula now. In this formula, what is TB now? TB is equal to delta TB plus T naught B. Delta TB is 1, T naught B is 100. So 101 is the answer. Very simple, correct? So answer for this question is, remember, C. Very simple. So the answer is C. Now, the 9th question. In this particular case, 9th question, what they have given, you have to understand. 0.5 molar aqueous solution of weak acid HX is 20% ionized if Kf for water is 1.86. The lowering in freezing point of the solution is they are asking. Lowering in freezing point of the solution. So, in this particular case, that is delta Tf. So, that is depression freezing point, lowering means, is equal to I into Kf into M. Correct? So, here, in this case, I you have to calculate. Kf is given 1.86. M is given 0.5. Now, to calculate I, what we will do? Direct formula you can use. I is equal to 1 plus alpha in case of the dissociation. But I will show you how it is. Hx give rise to H plus X minus. Correct? So, initially how many moles you have taken? 1 here, 0, 0 here. So, dissociated how many? Dissociated how many? Alpha. They have given alpha. Later we will substitute it. 20% means 0.2. Alpha. Here alpha. Here alpha. So 1 minus alpha. 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 So total moles. Total moles is equal to 1 minus alpha plus alpha plus alpha is equal to 1 plus alpha. We know that I is equal to. So number of moles after dissociation divided by number of moles before dissociation. So before dissociation is how much? 1 mole, right? 1 mole. So after dissociation is how much? 1 plus alpha. So 1 plus alpha divided by 1. So hence I told I is equal to 1 plus alpha. Directly you can take. Right? If I is equal to 1 plus alpha, alpha is 20%. 20% means 0.2. Alpha 0.2. 1 plus 0.2 is nothing but 1 plus 0.2 is nothing but 1.2. 1.2. So 1.2 into 1.86 into 0.5. You calculate this, you will get the answer around C. 1.2 into 0.5 is 0.6, correct? So 0.6, 1.2 half is 0.6 into 1.86, right? So 18 6 is how much? 18 5 is 90, 18 6 is 108, correct? Your answer is around 108, that is 1.08. 1.08 around 1.08 around is answer is B here, 9th question. Now, an aqueous solution of 1 molal in which 1 molal in Ki. See, aqueous solution is 1.0 molal in Ki. Which one will cause the vapor pressure of the solution to increase? That is very, very important point here. So this type of problem when they ask, remember, we have to be very careful. So now what happens if I add addition of NaCl? Addition of NaCl means the number of moles increases. Correct? NaCl means Na plus Cl minus I value is 2. So number of moles increases. When number of moles increases, remember vapor pressure is going to decrease. Correct? So Na to SO4. Always remember number of moles as it increases, vapor pressure is going to decrease. So Na to SO4. Na to SO4 also 3 moles you are going to get. Each dissociation because it is strong, correct? So Na to SO4 give rise to vapor pressure decreases. And here 1 molal Ki is there. Definitely 1 molal Ki if I add this Ki and this 1 molal Ki, definitely K plus I minus, it will also decrease the vapor pressure. Then what is the answer? Addition of water is the answer. Why addition of water is the answer? I will tell you. See, addition of the water, what it will do is, so addition of water to an aqueous solution of Ki causes the concentration of the solution to decrease. See, when I add water, concentration of the solution to decrease, thereby increasing the vapor pressure. When the concentration of the solution decreases, remember vapor pressure increases, we know that. So vapor pressure increases, definitely vapor pressure of the solution to increase. Addition of water is the best solution. So the answer for this question is D. So these are the 10 questions from solutions chapter. I hope it will help you for the NEET preparation. So if it helps, so if you are not subscribed to the channel, please subscribe to the channel. Thank you. Have a nice day.